With mirrors, we have two different types of mirrors. We have a concave mirror, which would look something like this, with a focal point here. So all the light coming into this mirror gets reflected through that focal point. If it's coming in from parallel at least, gets reflected through that focal point. We have a convex mirror, which looks like just the opposite side. Its focal point is going to be over here, but when we're talking about objects, the object is going to be located on this side. This is the reflective side of the mirror over here. And any light that's coming in parallel gets reflected away, sort of as if it were coming from that focal point there. So you get something like that. Like with lenses, we can do our ray diagrams that'll help us figure things out. So we have our concave mirror here. The focal point is going to be here. One kind of interesting side note here is that the focal point for a mirror is always half of its radius of curvature. Let's do it for the case of an object outside the focal point. For outside the focal point, we would draw a line that goes parallel to the mirror and then gets reflected back through the focal point. We would draw a line through the focal point and reflected back parallel. And then we could draw a line to the center of the mirror, and that one's going to get reflected at the same angle that it entered. And where those all converge, we get our image. In this case, it is an inverted image. And since the light rays are actually there, it is also a real image. Again, we could put a piece of paper there, and that image would show up on the piece of paper because the light rays are actually there. We could also have a concave mirror, a slightly different situation where we would be inside the focal point. So our focal point's there, and here's our object. So same sort of thing, parallel, and then through the focal point for one. But I can't go through the focal point and hit the mirror since the focal point's behind. So what I'll do is draw as if it came from the focal point and back parallel, and then to the center, and then an equal angle coming back out. Now notice none of these light rays converge, so what we have to do is trace that reflected light back behind the mirror as your eye would do to find out where that image forms. And where all three of those things converge, that's the location of our image. In this case, it is upright, and it is virtual. With a convex mirror, let's look at our two cases. Well, actually only one case for a convex mirror, because it's always going to be outside that focal point, because the focal point is always going to be on the inside part of the curvature. And so our object is always going to be here on the other side of a mirror for a convex mirror. So, kind of like before, first line comes in parallel and then would get reflected as if it came from that focal point. So it kind of looks like it came straight from there. Draw it as if it's going to the focal point and then gets reflected back parallel. And then to the center of the mirror and away at the same angle. Now, again, none of our light converges here, so we trace it back behind the mirror. We trace all our reflected lines. So we trace our parallel line back there and through the center back there, and we get our image right here. It is, again, a virtual image since none of the light is actually there. Our eyes just perceive it as traveling in a straight line from there. It is upright. And you'll also notice it's much smaller than our actual object. So definitely kind of some general rules to follow here. Right? We have the focal line that goes from our focal point and back parallel, line that goes in parallel back through the focal point, and then center. It's always angle in equals angle out, so equal angles there. And these are sort of the general rules to always follow for mirrors. You should notice that these are incredibly similar to what we do with lenses. It's just that they're drawn slightly different because the light is reflected rather than refracted. We also have what we could call a set of mirror equations to kind of do this with math rather than drawing things out to scale. Luckily for you, you already have those. Those are the same as the lens equations that we used previously. So what you have written down in your notes for the lens equation applies exactly the same for our mirror equations, just with some slight sign notations that we'll talk about in class.